In this video, I will show you how to choose the right reason to prove that two triangles are congruent. So we only have these 5 reasons. SSS stands for side, side, side. SAS stands for side, angle, side. ASA stands for angle, side, angle. AAS stands for angle, angle, side. And HL stands for hypotenuse-leg. This one is only for right triangles. So looking at problem number 1, you see by the markings that we have these 3 sides congruent to these 3 sides. And the way the markings work, this single mark corresponds to this single mark, which means that these 2 sides are congruent. So this one pair of sides represents an S. Another pair of congruent sides here and here, that's another S. And this third pair of congruent sides represents the third S. So this is what is meant by side, side, side congruence. We have to be a little bit more careful when we look at problem number 2. Notice that we have 2 angles and a side that are marked. The problem is we have 2 different statements that involve 2 angles and a side. How do I know if it's going to be angle, side, angle, or if it should be angle, angle, side? Well, the key is this. When you look at the statement angle, side, angle, notice how the S is in between the 2 A's. In other words, notice that the side is between the 2 angles. If you look at the picture, if the side that is marked congruent is between the 2 angles, that's how you know it will be angle, side, angle. If the side is not between the 2 angles, then it must be angle, angle, side. So notice in this case, we have one angle right here, and we have another angle over here. So yes, the congruent side is between the 2 angles. That's how we know it's going to be angle, side, angle. All right, looking at problem number 3. So I see here that we have 2 sides and an angle. So of the choices that we have here, the only one that involves 2 sides and an angle is this one right here. So this is our first guess. However, it is possible to have 2 sides. Hold on, let me draw that better. It's possible to have 2 sides and then have the angle not between the 2 sides. This does not prove triangles are congruent. So if I ever see SSA, then I'm going to circle the triangles can't be proven congruent. So it's important that the angle is between the 2 sides. So let's take a closer look. Well, here is one side, and then here is the other side. So you can see that the angle is between the 2 sides. So this will in fact be side, angle, side. The angle is between the 2 sides. Looking at problem number 4, we have 3 angles congruent to 3 angles. Now we are tempted to write angle, angle, angle. But we look up at the choices and we notice that's not a thing. There is no angle, angle, angle option. And that's because you can have 2 triangles, a big one and a small one, that have congruent angles. So angle, angle, angle is not an option. So we are going to say that the triangles cannot be proven congruent. If you choose triangles can't be proven congruent, you need to make sure you leave this line totally blank. Now look at problem number 5. Notice that we have 2 angles and a side. So our choices are, is this going to be angle, angle, side, or will it be angle, side, angle? All right, both of these involve two angles and a side. The way we choose is we ask ourselves, is the side between the two angles or not? Okay, if the side is between, we're going to choose this one. If the side is not between, then we're going to choose this one. So look at these two angles. I see that we have an angle here and we have an angle here. The side that would be between these two angles, you know what, I think it'll be clearer if I use dots. Okay, so we have angle P that's being marked, and we have angle O that is being marked. So the side that is between these two angles would be the segment connecting these vertices. So this is the side that's between the angles. Is that the side that's marked? No. The side that's marked is some other side. So the side is not between the two angles. So this is angle, angle, side. Angle, angle, side. If they had marked the angle, if they had marked the side between the angles, then it would be angle, side, angle. Okay, let me just get rid of that extra mark. Okay, how about problem number 6? Well, this one is pretty obvious. We have all three sides marked and all three sides marked. So that's clearly going to be side, side, side. Okay, look at problem number 7. On this problem, we have two sides and an angle. Okay, so that's either going to be side-side angle, which is not a thing. All right, if it turns out to be side-side angle, I'm going to pick this one. Or it's going to be side, angle, side. The question is the angle between the sides? Whoops, that's not how you spell between. Is the angle between the sides or not? So take a look. Here is one side that's marked congruent, and here is another side that's marked congruent. The angle between is where they meet. That's right here. Is that the angle that's marked congruent? Yes, it is. So the angle is between, so this is side, angle, side. Take a look at problem number 8. I see that we have two angles and a side. So the question is this going to be angle, angle, side, or will it be angle, side, angle? So the way we choose is we ask ourselves, is the side between the two angles? If so, we're going to pick this one. Or is the side not between? Then we're going to choose this one. Okay, well, let's analyze the two angles. I'm just going to pick one of these triangles to really look at. So here's one angle that's marked congruent. Here's another angle that's marked congruent. Okay, so here is the side between those angles. It's going to be the segment connecting those vertices. Is that the side that is marked congruent? Yes, it is. Okay, so the side is between the angles, which means this is angle, side, angle. Okay, look at problem number 9. If I focus on one of these triangles at a time, I see that we have two angles and a side. So this is either going to be angle, angle, side, or it will be angle, side, angle. And once again, the difference is if the side is between the two angles, all right, I'll just put between right here, then I'm going to pick this one. If the side is not between the two angles, then I'm going to pick this one. Let's focus on the two angles that are marked. Angle B is marked congruent, and so is angle A. So the side that's between these two angles will be the segment connecting these two vertices. Is this segment the side that is marked congruent? No, it is not. The side that's marked congruent is way over here. So the side is not between the two angles. That means this is angle, angle, side. So we're going to put angle, angle, side. All right, let's look at the next one. Again, focus on one triangle at a time. So again, I see that we have two angles and a side. So this is either going to be angle, angle, side, or it will be angle, side, angle. And the difference is, if the side is between the two angles, then it's angle, side, angle. If the side is not between the two angles, then it's angle, angle, side. So here are the two angles, C and A. The side that is between these two angles is simply the segment connecting these two angles. Is that the side that is marked congruent? Yes, it is. So the side is between the two angles. That's why this is angle, side, angle. So we're going to pick angle, side, angle. All right, look at problem number 11. Focus your eyes on one triangle at a time. I notice that we have two sides and an angle. So this is either going to be side, angle, side, or it's going to be side, side, angle. Side, side, angle is not a thing. If it turns out to be side, side, angle, I'm going to circle triangles can't be proven congruent. So watch out for that. So we will choose side, angle, side if the angle is between the two sides. So the best way to do this is to trace the two sides. So here's one side, and here's the other side that's marked. Look where they meet. Those two sides meet right here at angle A. Is that the angle that is marked? Yes, it is. So the angle is between the two sides. So that makes this side, angle, side. All right, let's just look at a few more. Looking at problem number 12. Let's focus on one triangle at a time. I'm noticing that we have two sides and an angle. Actually, before I even get too carried away, there's something special about number 12. Notice that we have a right angle here. All right, both of these are right angles. There's one option, hypotenuse-leg, that only applies to right triangles. So whenever we have a right triangle, we should stop and ask ourselves, wait a minute, is this hypotenuse-leg? Just because it's a right triangle doesn't mean it will be hypotenuse-leg. You have to know what the word hypotenuse means. So when I look at this triangle, what part of this is the hypotenuse? Do you know? So this would be the hypotenuse right here. The hypotenuse is always the side that is across from the 90-degree angle. So this is the hypotenuse. Now, any other side is going to be a leg. So notice that we have the hypotenuse marked congruent. And then we have another side, which would be a leg. So we have the hypotenuse and we have a leg. That makes this hypotenuse leg. So if you see that it's a right triangle, check to see if you have a hypotenuse and a leg marked congruent. So problem number 13. This is not a right triangle, so it cannot be hypotenuse leg. So we're going to go back to our normal analysis where we say things like, we have two sides and an angle. So that means this is either going to be side-side angle or it will be side angle side. It all depends on whether or not the angle is between the two sides. If it is, then it'll be side angle side. If the angle is not between the two sides, that means it is a side-side angle situation. However, side-side angle is not a thing. It does not prove triangles are congruent. So if that's the case, then we will circle triangles can't be proven congruent. So let's look at the sides and the angle and see if the angle is between the two sides. Let's trace the two sides. So here is one side that's marked congruent. All right, here is another side that is marked congruent. Look where these two sides meet. They meet right here. That means this is the angle that is between the two sides. Is that the angle that is marked congruent? No, it is not. The angle that's marked congruent is way down here. So the angle is not between the two sides. That makes it a side-side angle situation. But do not put side-side angle on this line, whatever you do. Side-side angle does not prove anything. Instead, go ahead and circle the triangles cannot be proven congruent. Leave this blank. Okay, how about number 14? I'm noticing that these triangles are right angles. They're right triangles. So does that automatically mean it's going to be hypotenuse leg? Well, not so fast. Let's stop and ask ourselves, do we have a hypotenuse and a leg marked congruent? So I'm going to focus on just one triangle at a time. So I'm going to focus on this triangle for now. Okay, the hypotenuse is this side right here. The hypotenuse is always across from the 90-degree angle. Okay, this is the hypotenuse. Is the hypotenuse marked congruent? No, it is not. The hypotenuse is not marked. That means this cannot be hypotenuse leg. So do not put HL. Instead, we have to do our general analysis where we look at this just in terms of sides and angles. So notice as you focus on this triangle, we have two sides and an angle. So this is either going to be side-side angle or it's going to be side angle side. Okay, and what matters is the angle between the two sides. If so, it'll be side angle side. If not, we're going to say the triangles cannot be proven congruent because side-side angle is not a thing. So here's one side that's marked congruent. Here is another side that is marked congruent. Look where those two sides meet. They meet here at angle C. Is that the angle that is marked congruent? Yes, because the right angle is the marking that is showing which angle is congruent. The right angles are congruent. So the angle marked is between the two sides. That makes this a side angle side situation. So we're going to put side angle side. Okay, just a few more. So for this, just focus on one triangle at a time. So I'm really going to focus my eyes on this triangle up here at the top. All right, because the bottom triangle is just a mirror image of this. So I'm seeing that we have two sides and an angle. So the question is, will this be side-side angle, or will it be side, angle, side? As we've said many times, the difference is for side, angle, side, the angle must be between the two sides. So let's see if it is or not. So here's one side that is marked congruent. Here is another side that is marked congruent. Look where they meet. They meet right here. Now, is that the angle that is marked congruent? Yes, it is. So the angle is between the two sides, which makes this a side, angle, side situation. Okay, look at number 16. Focus your eyes on the upper triangle only. Notice how similar this is to problem number 15. Again, we have two sides and an angle. So again, this is either going to be side-side angle or side angle side. We ask ourselves, is the angle between the two sides? Well, here's one side that's marked congruent. Here's the other side that's marked congruent. Here's where they meet. Is this the angle that is marked congruent? No. The angle that's marked congruent is way over here. This angle is not between the two sides. That means this is a side-side angle situation, but side-side angle does not exist. It does not prove that triangles are congruent. Do not put side-side angle on this line, ever. Instead, you say the triangles can't be proven congruent. Last one. Focus your eyes on the upper triangle. I'm noticing that these are right triangles, so maybe it will be hypotenuse-leg, but don't assume, check. So start by asking yourself, which one of these sides is the hypotenuse? Well, the hypotenuse is always across from the 90-degree angle. So that means this is the hypotenuse. I can draw a better line than that. This is the hypotenuse. Look at that straight line, you guys. And notice that is one of the sides that is marked. So we do have a hypotenuse. Any other side of a right triangle is called a leg. So including this side over here, this would be a leg. Okay, so I'm just going to erase my little circle here so I can emphasize that this is the hypotenuse and this is a leg, so this will be hypotenuse leg.